Molar scattering is the name given to electron-electron scattering in quantum field theory, named after the Danish physicist Christian Møller. The electron interaction that is idealized in Molar scattering forms the theoretical basis of many familiar phenomena such as the repulsion of electrons in the helium atom. While formerly many particle colliders were designed specifically for electron-electron collisions, more recently electron-positron colliders have become more common. Nevertheless, Molar scattering remains a paradigmatic process within the theory of particle interactions. We can express this process in the usual notation, often used in particle physics. In quantum electrodynamics, there are two tree-level Feynman diagrams describing the process. A T-channel diagram in which the electrons exchange a photon and a similar U-channel diagram. Crossing symmetry, one of the tricks often used to evaluate Feynman diagrams, in this case implies that Molar scattering should have the same cross-section as Baber scattering. In the electroweak theory, the process is instead described by four tree-level diagrams. The two from QED in an identical pair in which a Z boson is exchanged instead of a photon. The weak force is purely left-handed, but the weak and electromagnetic forces mix into the particles we observe. The photon is symmetric by construction, but the Z boson prefers left-handed particles to right-handed particles. Thus the cross-sections for left-handed electrons and right-handed differ. The difference was first noticed by the Russian physicist Yakov Zeldovich in 1959, but at the time he believed the parity-violating asymmetry was too small to be observed. This parity-violating asymmetry can be measured by firing a polarized beam of electrons through an unpolarized electron target, as was done by an experiment at the Stanford Linear Accelerator Center, SLACE 158. The asymmetry in Molar scattering is, where m is the electron mass, e the energy of the incoming electron, is Fermi's constant, is the fine structure constant, is the scattering angle in the center of mass frame, and is the weak mixing angle, also known as the Weinberg angle. QED computation.